Yeah, okay. So in case of the base R, which comes with its own, you can say, graphical functions, they are there. You can do a lot of like plots using those ones, but most of them are quite difficult to, you can say, sort of customize it depending upon the needs of the user. So keeping that in mind, basically, David Hadley Wickham actually developed ggplot2, and GG stands for basically grammar for graphics. And what the ggplot2 provides is a lot of customization and flexibility with respect to plotting graphs in R. And that makes it really, really powerful. Other than ggplot, there are additional packages out there. So some of them like ggRepel or Grid, or all those packages are then built around ggplot2 to further give some sort of, you can say, flexibility to the user uh, to further modify or further customize these graphs, and because of which it has become really, really very powerful. So when we start looking, so we will mainly talk about ggplot2. I will not venture into any other packages. So in case of if you look at the ggplot2, if you try to understand it, ggplot2 can be seen as a multi-layered plotting tool. So it has different layers, and each of these layers can be manipulated independently of each other. So if you look at it, it starts with the data layer where we specify basically what's the data set we will be using in terms of what will be our output would be. Then we have aesthetics. So aesthetics is where you specify of the given data set, or let's say of a given table, which column would you like to use as an x-axis or y-axis, or if you want to group certain those particular data set based on certain criteria, all those can be specified in aesthetics. Then basically geometries. Geometries define like what kind of plot are you looking for? Are you trying to do a scatter plot? Are you doing a histogram? Are you doing to do box plot? Or basically, let's say, whether you want to do a violin plot. So all those things, the geometries are generally defined in the geometric layer. Then there are facets. Facets are mainly when you're trying to group your data, or basically you plot your data in, let's say, X and Y columns. So you subset your data and try to separate out into based on certain criteria. So they will make more sense once we go into there and look for their functions. Then we have a layer called statistics. So in the statistics layers, you can include, like in scatter, then there is a coordinates layer that is mainly the coordinate layer is mainly involved into defining, you can say, the axis and the axis which we are using to plot it. Finally, there is the themes. Themes is more to like what's your final representation, or how your final output you would like to. So you can think about themes as in like different publications has different requirements, how their graphs has to be generated, what font has to be used, what size font has to be used. So all those are very particular from, sometimes very particular from journal to journal. So themes can provide you that flexibility. So it lets you design your own theme, and that theme could be very specific to a paper or an article or something which you want to keep it consistently across all your figures. Then if you apply that theme, everything get formatted according to that particular theme. So that's the kind of flexibility the themes provide. So again, here are basically there are layers, and each layer, what are the different variables that can be defined. So if you're looking at the data, we are primarily looking into we are importing a data set. So this could be a generally a data frame. So the kind of data which will be like to pull it in, and then certain columns you want to select and want to plot them. Aesthetics is where you specify X and Y axis. You also can specify like what kind of color, if it's a scatter plot, what kind of color do you want to have for your dots or each of the data points. Fill is generally, let's say you're doing a box plot or a histogram, what kind of color you want to fill into your bars. Size is again basically the size of your data points. We will see how these can be used quite effectively. Alpha represents the transparency associated with each of the data points. So how these, so sometimes it so happens that you have multiple data points overlapping each other, and without transparency, they won't look very great. But if you set some sort of a transparency that, so that you can see that there are two data points at that particular place or location. We'll see some examples of those as well. Then there is a shape associated with it. So you can have data points represented into different shapes. Then line width and line type. Those are the aesthetics associated, variables associated with aesthetics. Then we can look at geometries. So geometries, you want to do point, like a scatter plot. We can do lines. That's basically, let's say, line fitting through our scatter plot, histogram, bar plot, or box plot. All those things are different geometries. There are more. They are not. These are not the only ones. They are density plots. Then you can see Voiland plots. There are many more out there, but these are the few just to illustrate what geometries mean. Then there are facets. Facets are like you putting your data rows and columns. We'll look into those ones. They will, especially the facets part makes more sense once we start looking at particular kind of data set. Statistics is mostly like binning of your data. If you're trying to do a histogram or a bar plot, you want to bin your data in a certain way. That can be, so the histogram and bar plot comes with their own binning, you can say function associated with it or parameter associated with it. But other than that, also you can do different kind of binning as well. You can do smoothing. So basically, if a line fitting through and you want to smooth it out, descriptive, you can also use the descriptive of inferential statistics in the plots. Coordinates, there are different kind of coordinates you can use, and mostly we will be focusing on the Cartesian one, but there are other ones as well. Finally, as I mentioned, the themes is actually to help you set up the background of your graphs, their axis label, font size, font type, all those can be set up in the themes layer. And each of these layers can be manipulated independently. You don't have to rewrite everything to manipulate one particular layer. You can just modify one layer and everything should work. Everything else get customized based on modification that is applied to a given particular layer. So here is an example. So when we say ggplot empty cars, so empty cars is one of the data frames that comes with base R. So it has information about certain number of cars and certain attributes associated with each of those cars. We'll look into that particular data frame in just a short while. So in empty cars, when you say ggplot empty cars, ggplot actually start building a space for you to do the plot. So it generates a white blank canvas. But it still doesn't know of the empty cars, which column would you like to use, x-axis or y-axis. So then we specify aesthetics layers. So aesthetics layers is which column values we'll be using as an x, or you can say, which of those, which column we'll be using as an x-axis and which one we'll be using as y-axis. Would we be taking advantage of shape, color, size, and labels part? So those are the different ones. We will see examples and they will make more clear, like how do they help in plotting these graphs. So we put two layers like data and aesthetics. The final layer is where we specify, now we have data. We also specified, let's say in this layer, what is going to be our x-axis, what's going to be y-axis. And then the next thing comes, like what we want to plot. Like we haven't specified whether we want a scatter plot, we would like a bar plot, histogram, a Voiland plot, or any other kind of plot. So that's where the geometries come into it. So it's, for example, in this one, we are using a geometry called a geom point, which plots scatter plots. So once we have these three parameters basically mentioned, these are the really fundamental three layers that we need to specify just to get the graph going. Anything else, the rest of the layers are pretty much, you can say, customization or beautification of the rest of the graph. But they're again very, very powerful when you start using those ones. So let's look into that one. So here we are trying to, so this is the facet as grid. So we are trying to plot, or basically trying to get the graph split based on certain parameter. Again, let's go to that part and it'll make more sense. Here we're trying to apply some statistical methods. And then basically some scaling of coordinates, like you want to change the axis of the coordinates, or you want to, so let's say by default, the x-axis goes from 0 to 30, but you would like to go it from 35, so that certain data labels which are not clearly visible could be visible. So you can set up those things. limits of your x-axis, limits of your y-axis, all those can be done. So the way it generally is after every layer you add, you put a plus sign and add the next layer, plus sign and another layer. So every time you add plus, you actually end up adding a new layer to it. And that layer modifies the existing plot or existing graph that has been generated before that. So an example of this one is particularly this one, and in a short while we will plot this one. So here we are using MTCast dataset, and here it as an x-axis. Unfortunately, the label is not visible, but in x-axis I have the weight of the car, and on y-axis I have miles per gallon, which is like the fuel efficiency of a given car. So I'm looking, so the data points are scattered. So you can see there's a sort of like a negative, forget about the color, shape, and size of the data points. But if we ignore those ones, then you can see there is a negative correlation between miles per gallon versus the weight. So as the weight increases, the fuel efficiency goes down. Now in these data points, we are adding additional dimensions. So let's say our cars are two different categories. There are automatic cars and there are manual cars. So now based on the data sizes or data shapes, we can include that information. So basically, or the surrounds are automatic cars and triangles are manual cars. So again, you see that the manual cars tend to have a better fuel efficiency as compared to the automatic cars. Then I have added some other information, like is the horsepower divided by the weight. It doesn't convey anything, but just being included. But you can see that that variable is also included, and that is represented as a function of size of the each data point. So you can see these triangles are of different sizes. That represents, the bigger the size, the bigger is this particular ratio, HPY weight, and the smaller the size of any of these data points, lower is that particular ratio. The third information, which is coded in form of color here, is basically the cylinders. So whether the cars are 4-cylinder, 6-cylinder, or 8-cylinder cars. So you can see all the basically 4-cylinder cars are better efficiency than the 6-cylinder, than the 8-cylinder cars. The other way you can also see that the higher the more the weight of the car, higher is the cylinders associated for those particular cars. So in a way, if you look at it in a single graph, we have 5 dimensions of our data being represented. So we have their weight, they have miles per gallon. We also have information about how automatic and manual cars are basically, you can say, for what trend those cars follow, what trend this particular ratio follows, and how basically the cars with respect to the cylinder information is spread out. So this is the one thing which makes R really, really powerful. So you keep adding the dimension, and it allows you to do that. And it can be done with very, very simple coding. It doesn't need really any kind of sophistication associated with it. So this is pretty much the introduction I wanted to give, and I will move now from here into the R Studio, where we will do some of these plots using exactly the same data set. Before I go there, anyone has any questions with respect to whatever I have described here so far? Okay, so let's go to basically use ggplot2. So if you're going to use ggplot2, you have to install it. So you have to use this particular function, install.packages, and within the quotes, ggplot2. You need to have it installed before you start using the functions of ggplot2. Once you have installed it, then what we're going to do, we're going to actually load this particular library. And the function to do that is either require or library. Both of them should work, library ggplot2. And if you do that, that particular package should be loaded. Now all the functions of ggplot are available. Anyone want me to wait while they're trying to install these packages? Or you can basically install it later after the class also. But if you want me to wait, I am happy to wait. Okay. I don't think anybody says anything. So I'm going to go ahead and just demonstrate what kind of data set we are playing with. So as I said, empty cars is a data set which comes with base R. So let's have a brief look at, or basically look at the head of that particular table, that particular information, or that data frame. So let me replot it. Okay, redisplay the header. So basically the columns or the rows represents a different
Jay,
kind of, yeah, sorry, go ahead.
your screen is not changed.
Oh, okay. My screen is paused. Okay.
Yeah, I mean, I see like the presentation on the screen. So yeah, something like is trouble.
Okay. So now it got paused and I'm not really sure why. So where did it happen? At what point it happened? Just now or before?
It's on ggplot2.
Oh,
The
okay. Right
slides
now
on the
it's there.
time.
So, but when I was trying to describe that one, was that working or wasn't working?
When you started describing the install, it didn't change.
Oh, okay. Now here, can you see this? Oh, okay. Again, it's paused. I don't know why it's paused. Okay. So let me switch, and it's getting paused. Oh, okay. Wait a minute. Wait a minute. I think I made a mistake. Okay, sorry. I'm going to stop the share and then reshare it. Thank you. Thank you for letting me know. Okay. So let's try this. And now you can see my RStudio screen, right?
Yeah, it's right now.
Okay. Okay. Thank you. Thank you so much. Okay. So essentially, the one thing which I was describing before was to install the package ggplot2. So you can do that install.packages and within the code ggplot2, that will install ggplot2 for you in your RStudio. Then you have to load the package. So we can either use require ggplot2 or we can use library ggplot2. Both of them should work. There are some differences between the two of those, which we discussed right at the beginning. So when we started looking into started R basically. So what I want to look at that, so we are going to use the empty cars. So I just displayed the head of the empty cars, and you can see the rows actually represents the different cars, and the columns represents the different attributes that are associated with these particular cars. Now, if you want to see what each of these columns represents, what's the so you can actually look into the help file of empty cars. So you can say question mark empty cars. And what you'll see here is there's some information about these. If you go down each of these columns, MPG is miles per gallon, CYL is cylinders, displacement is basically is the engine size, which generally some places are in liters, but here it is in cubic inches. Horsepower, and DRAT is the real axle ratio. I have no idea what that is. WT is the weight of the cars in pounds per 1,000 pounds, basically 1,000 pounds. A CUSEC is, I think, is a quarter of how much time does it take to go for. I think this pretty much related something to related with the speed. I would say quick speed, but I am not 100% sure how that has been calculated. VS is the type of engine, whether it's a V-shaped or a straight engine. AM is the transmission of a car, whether the car is an automatic or is a manual. If it is 0, it's an automatic, 1 is manual. So you can see that basically the AM column has values 1s and 0s, same as VS column has 0s and 1s. In VS column, 0 is V-shaped, 1 is straight. Gears, the total number of forward gears in the car, and carb is the number of carburetors that particular car has. So we possibly, so any data set which comes with any of these packages, generally if you do question mark, they should be able to give you some idea about like what that data set is. So the next thing I would like to look at, if I'm doing a graph, I would like to look like how big is this data set. So this is not really big. There are 32 rows and 11 columns. So there are basically information about 32 different cars, and there are represented 11 different attributes of that particular data set is being included over here. Now with that particular information, let's start doing some sort of graphics or plots over here. So as I said, the ggplot, if you simply say ggplot cars, empty cars. So what it does, it displays a screen. It's just like a blank slate it has created. Okay, yeah, we are going to start going to do some sort of a graphs, but we haven't described anything else. We haven't described like what is going to be our axis, which column we want to use as an x-axis, which column we want to use as a y-axis. So if you're using, so before going that, if you're using your own data sets, that's in or data frames, your data frame name would come here. And of that data frame, the column names would be coming as which one you want, whichever we would like to use as x-axis or whichever we would like to use as y-axis. So now we have specified that we are going to use empty cast, but we can modify the same code as ggplot empty cast, comma AEX, x equals to weight and y equals to miles per gallon. Now in this one, we also specified, okay, what's going to be our x-axis, y is going to be our y-axis. And once you execute this line of code, it's going to now start giving you, okay, this is your x-axis. That's how the distribution of weight is from 0 to maybe 6. So the maximum weight is 6,000 pounds. And miles per gallon ranges from, let's say, 10 to maybe maximum around 35, maybe not be 35. You don't have to go like step by step like this. If you're plotting your own, you could directly write this one, but I'm just trying to demonstrate like how when you start adding each layer, how the graph changes. Okay, so now we have the information we have specified in terms of what data frame we are using, what is going to be our x-axis, and what is going to be y-axis. But we still haven't given any information of our x-axis data, data coming from y-axis, what we would like to do with it. What kind of plot do we want? What geometry we are interested into? So here it's what I'm using is a geom point geometry, and the geom point geometry will help us to basically do a scatter plot. So if I am actually have a data set and I want to plot it, I'm not going to plot, I will directly basically writing down this complete line, and that should be more than enough to actually get your graph going. So I will type it just to show one thing. Okay, let me go to the previous code and into this one. So this was our basically the data layer and aesthetic layer. Now I'm adding the geometry layer. So I'm going to say geom underscore. The moment I say geom underscore, it lists out a whole range of geometries that can be used to do a graph, right? So if any of the geometries you want to know a little bit more about, you can use again the help function. So put question mark and then put any of the geometries, and it's going to tell you in the help file what are the different variables you can set up to get that geometry working. So I'm going to use geom point, so which is for doing a scatter plot or putting points. And once I execute it, now I got a scatter plot. So you can see there's a negative correlation between the distribution between the negative correlation between miles per gallon and weight. So as the weight increases, your fuel efficiency goes down. Now in this case, we can change, so as aesthetic, so this is by default colors and everything. So let's say we want to change that one, so we can do that. So just because we are changing the points, data point color, so we'll change the geometry related attributes. So geometry related attributes are like color. So you can say color equals to, let's say, red. And also color equals to red. We want the size to be a little bigger. So you can say size equals to 3. And we can also, what else can be? Size, color, size, and maybe let's say alpha, which is generally the transparency. So let me plot before without alpha and with alpha so that you see what I mean by transparency. So this is the data points. Now this data size or the points, the plot has increased in its size, or each of the data point has increased its in size. Now the color is red, but you can see there is an overlap of these data sets over here, and this doesn't look really very neat in the current format. But let's say if we add transparency to it, so we say alpha equals to 0. Let's say 5. And now it looks much better. You can pretty much look at the boundaries of each of these data points. So you can change this alpha values to more or less, whichever way you would like to go through. So it becomes more or less transparent. And it's quite helps that if you have, let's say, another line going through or some other data point there, they can be seen if you add alpha to it. Now, one important thing which I want to point out, color equals to red. So these colors, if you would like to see what other colors are permissible in R, then the best place to go and check out is basically on our on Google, basically on browser, on any browser you move. And let me see if I can pull out something. Okay, here. So here, if I want to look what are the, so I will say R color palette. Oh, this is called color brewer, but you can say R color Again, Color Brewer is another package which can help you to have different colors. But if you say our color palettes, and maybe look into images, once you go in images, there is a different kind of color. So these are the different colors you can specify in R. You have to click on those ones. So these are the different ways you can see different kind of colors over there. And these are the different transparencies of each of those ones. Also, there is, hopefully I can pick up, maybe this one. Let me see if I can zoom in. Oh yeah, this one actually. Let me pull it out. This one. Sorry. Let me close this one. Okay. Now here, if you can see that each color, these are the different colors, and there's some sort of a code associated with each of these colors. So if you want to use any of these colors, you can pick up the code from here and go to the R Studio and just put, instead of red, you put that code inside the quotes, and that will take up and then basically use that particular colors. All the colors possibly are permissible, but they may be named differently. So let's say if magenta or something like you use and it doesn't display, primarily maybe because the color is there, but it's just maybe called a little bit differently. So the best thing is just go on a browser and look for our color palettes, and you can pick up colors from there as per your requirement. Okay. Any questions so far from here? So if I want to just generate this graph, I don't have to do any of these lines before. This one line should be able to generate exactly the graph which I'm seeing. What I was going was step by step to demonstrate like how each layer is getting added up. Okay. Any questions here so far? Okay. Now let's go to the next one. And now I'm going to change a little bit different. So line number 14, if you look at, again, the aesthetics are pretty much the same, but what I'm now, instead of using a color, I want to, let's say, use the color to display a little bit more information. Like, so one of the columns in our data set is the displacement, so which is this one. So displacement is a continuous variable. And so I want to have that information also displayed of each of these particular data points. So that's now what I'm going to do is in aesthetics, I'm going to say color equals to displacement. So display the color based on the displacement value. So how does that work? So let me print it out. Now you can see that it will display a gradient of displacement. It's a gradient of blue. So the light blue has the highest displacement. Displacement is generally the volume of the engine. So it's a higher volume, and the darker class has the lower volume. So you can see that the cars which has lesser displacement or lower volumes, volume engines, they have more fuel efficiency compared to the ones which have higher ones. And now what we have, the information about displacement is now coded in the form of the shade of a particular color. So we have added like one more dimension to the graph which we have generated over here. Okay. Now here, so this is, you can use the same. So here we use color to basically show a continuous variable whose value changes from 100 to 400, or start maybe lower, but is continuously changing. But sometimes our values may not be continuous ones. They may be more like discrete. So for example, let's say cylinders. The cars are generally here. So let's see how many cylinders we have in this particular table. So the command for that one is use the command called table. And then you can say empty cars dollar cylinder. So it's going to, what is going to present the data in the cylinder column in the form of a table and its frequency. So it tells you that, okay, these are 3 different cylinders are available. Or the cars have 3 different cylinder types, 4, 6, and 8. There are 11 observations or 11 cars which has 4 cylinders, 7 observations or 7 cars with 6 cylinders, and 14 observations, or you can say 14 rows or 14 cars with 8 cylinders. Now we want to basically display this information. We want to color these data points based on the cylinder type. Now this is not a continuous variable, right? So though these are numbers, but these are 3 different categories, if you can think of. If you think of, it's like a category of cars having 4 cylinders, a category of cars with 6 cylinders, and category of car as 8 cylinders. And categories we generally represent by using factors. So we will factor this particular column and then color these data points. And that's basically what we are achieving in line number 16. Okay. What we are doing here is, again, the data aesthetics are pretty much same, X and Y. Till here, everything is same as what we have been doing. Now, what I'm saying, color equals to factor cylinder. So basically, take the data from the empty car cylinder column, and in that one, factorize the data. Once you factorize the data, the factor will have 3 levels. The level will be 4, 6, and 8. Levels are like categories. So it will have 3 categories, 4, 6, and 8, and then it will basically assign only 3 colors to our data points. And then we're doing a scatter plot as we have been doing previously. So if you execute this line, what you'll see now that basically the information what we are seeing in the scatter plot are also displaying the cylinder type of each car. And you can see the smaller size weight cars are lesser cylinder, and basically green are intermediate, and 8-cylinder cars are generally heavy. And there is negative correlation with respect to the fuel efficiency as fuel efficiency. I won't say negative correlation because they all are 4 cylinders, but you can say, but if you look across the categories, yeah, there is basically the 4-cylinder cars are more fuel efficient as compared to 8-cylinder cars. Right? So any other column we could have used to do this exactly the same thing. So if you want to, let's say, gears, if we want to look at the gear, how the gears value changes, so we can factorize again gears. Let's first look at how the gear table looks like. So, okay, the 3-gear car, 4-gear car, and 5-gear cars. And let's plot that one into our data set. Since it's a category, so I'm going to simply change the cylinder value to the gear value. And now the colors will be mostly on the type of gears. So you can see the cars, wow, there's a range of cars like 3 gears, because these are more, okay, these cars have only 3 gears. These cars have higher gears, 4 or 5. And the reason behind it doesn't make sense that the cars which are basically you can say higher cylinders has less gear. The primary reason is because these are the automatic cars. The automatic cars are maybe you have parking and some gear 1 or drive, or maybe 1 more gear. So that's why it says only 3 gears. So these cars are, the red cars are primarily the 3-gear cars are the automatic cars. That's the reason why you see them here. But irrespective of that, this is the way you can actually put your factor data inside the plot. My recommendation is to go there and play with this data set as much as possible, do different kind of graphs, try to do different kind of plots. And some of the graphs may work fine, but sometimes it may not. Work fine basically means if you encounter error, just change it a little bit different and then play with it. The more you play with it, the more you will develop an understanding how the whole code is working. All right, so the next code line of code is nothing but just to help you. So let's say this is the default coloring of this one, but you want to change the coloring. So we can do that as well. So this one is our default display. The 8 is listed last, 4 is listed 4, 6, and 8. You want to list it the other way around, you want to change the color. All those things, for some reason you want to do it. So there is a code that can help you to do that. Now it says actually the colors are being changed. You can change the, I would say change the alpha value. They will look much better. But right now, oh, so where is that? Okay. So you can change geom point, and maybe here itself you can change it. My alpha. Let's change there. 0.5. Yeah, so this is a little bit better color rather than having really strong. So based on the taste. So if the way you like, you can customize this whole graph. That's the main thing I want to convey over here. So the next code is again doing same using this data frame, using this column as x-axis, this column as y-axis. Now, rather than having changing the color, let's say we want to, the information we want to show here is basically the size of the engine, the one which we used here. So let me plot that one, and then this is the size of the engine. Okay, so these are the highest engine volumes, these are lower engine volumes. Now we believe that rather than the color, the size of the data, if the size of each data point will be a much better way to communicate this particular information. So then what we can do is we can, instead of color, and did we use anything else? No, color. Yeah, we use color. So rather than using color, we can have you use the size of the data points to display the information coming from the column displacement or engine volume. So if you do that, it will come something like this. So now the data points are indicating, the size of the data point will indicate what the volume of the engine is. So you can see, yeah, the bigger the data point, the larger is the volume, smaller the data point, smaller is the size of the engine is. So these are the different ways. The idea here I'm trying to convey is there are different ways you can convey the same information. Okay. And finally, this is the plot which I had in the slide. So we have the same empty cars. We are using the same aesthetics. We are using color. Now we are using color to indicate the cylinder type of the car. So 4, 6, or 8. Size we are indicating to indicate the dispersion, which is the volume of the car, volume of the engine, and the shape we are going to use to tell us whether the car is an automatic or the car is a manual. And again, we are going to be doing a scatter plot. So let me execute this live. Okay, now you can see that this particular same information, but now the shape of the object is letting us know whether the car is a manual or an automatic. 0 is automatic, 1 is manual. So basically you can say the circle ones are the automatic. So all the cars are here automatic, and that pretty much works with the gears we were looking at. All the cars here, we had only 3 gears because they were automatic. These cars are mostly manual. And the color is basically indicating the cylinder types, whether the car is 4-cylinder, 6-cylinder, or 8-cylinder, and the size of the data points is displaying the information regarding the size of the engine. So again, we have a 5-dimensional plot, or in a single plot, we are conveying the 5 different information about the cars. Okay. So yeah, so we're done with that particular data set. Now the thing is, so this is okay. Now the next thing which I want to do, we want to do, so we look at a scatter plot. Let's do a bar graph. And bar graph is like how many cars exist in a different categories. So we have to definitely have to pick up one of the columns which has categories. So let's say we will see, okay, cylinders. So the cylinders are of 4, 6, and 8 type. So you want to build a bar graph which group the cars based on the cylinder types and displays how many cars exist in each of the cylinder, each of these categories. So now your x-axis. So since we are using only the cylinders, the count function is performed by default by ggplot2, and that is going to display the information. So we are using empty cars. We are using to factorize the column. We're using the cylinder type and using a geom bar, which is a bar graph, and it's going to factorize the cylinder. So there are 3 categories, 4, 6, and 8. And the number of cars in each categories are displayed here. So 4 has 11, 6 has, I think, 8, or maybe 4, 6, or something like that. And 8 has 15 or 14, something like that. So, but yeah, that's what pretty much we're generating a bar graph from here. We can change the color that goes in each one of those. So let's say if you don't like the color being black or gray, you can change fill equals to red. And also we can again set up the alpha value. So the transparency is going to be 0.3. Hopefully it will work fine. So yeah, it did exactly the same graph. We changed the color, we changed the alpha value. So we can modify this graph as we would like. Now we know that, so these are cars of 4 cylinders, 6 cylinders, and 8 cylinder. Now we want to see, okay, how many of these cars in each category or in each of the cylinder type, what's the car, whether the car, how many cars are automatic and how many cars are manual. So this is a little bit further adding another dimension to this data. So we want to split these bars, the number of observation in 4 by, we are going to display the information about how many cars were automatic and how many cars were basically manual. And we want to display that information based using the color that is being filled over here. So that's that code which is over here. We are using ggplot2, empty cars, aesthetics, and x is equal to, again, the same for what we have been using before for bar plot or bar graph. But then we are saying fill the colors after factorizing AM. AM is the automatic and manual column. So it is going to factorize 0 and 1, and then color based on that one. And what it looks like is something like this. So it can say that when the cars are a 4, majority of the cars are basically manual. Majority of the cars are manual. A small proportion are automatic. 6 has an pretty much like equal distribution. 8, most of the cars are actually automatic. A very small fraction of those ones are manual. Any questions still here with respect to anything what we're looking here? These are simple plots. The idea here is I'm trying to convey is that it can be customized in n number of different ways to display your information the way you would like to have it. Okay. So the next thing what we're looking at is basically trying. Oh, go ahead.
Hey Vijendra, I just like a random question. So just to know, is there any way, like what sort of plots we can make? I mean, it's very hard to imagine what sort of plot you can make. So is there any way to know, like using the ggplot kind of like ways of plot we can make?
So basically, it's going to be entirely. You mean to say, let's say you have a data, but you want to figure out which is the best one to display your information, is something like that?
Yes, something sort of that. Yeah.
Yeah. So the best thing I would recommend is, so if you're working in a field, like people would have published papers, and then you can look into how different people have used different kind of graphs to put it. And you can choose one of those ones which you, in your opinions, is conveying the data information in the most efficient way. ggplot by itself doesn't have any inbuilt which can suggest to you, okay, this is what you need to do. That has to come from an individual's own research or own data type, like what you would like to plot. So for example, if you want to do a box plot, do you want to show your box data into a box plot? If I generally if I try to do anything in box plot, I prefer more of a violin plot than a box plot, because while the violin plot has exactly the same information as box plot, but also tells you something about distribution of the data in unlike the box plot. So I prefer violin plots a little better, but then it's entirely depends upon what you would like to convey to the you can say whether it's a reviewer or your audience, and you think, okay, which is the best way, this would be the best graph that can actually convey the message you are trying to deliver. By ggplot by itself doesn't have any inbuilt function that can suggest to you that, okay, this would be the best one. No, you can try different ones and then choose the one which were you, but the final decision has to be made by you. All right. Okay. So now here we are going is trying to save a is achieving the same thing what we have been doing before, but this time we are actually saving the plots in a variable. So you can say creating variables and plotting. So here we have, in this one we have basically specified that P, we are going to use ggplot, empty cars, aesthetics is X is equal to after factorization of the cylinder. That's what we are going to use. And now from the P value, from the P, we can do, where did I go? Okay, we can do P geom, simply say P plus geom bar. Then it's going to play basically plot the bar graph. And we can also say that we are going to use the same data set, and hopefully this works. I'm not 100% sure, but let's try. Geom underscore violin. Yeah, okay. Sorry about that. That's a lowercase p. Ooh, what happened? Why density requires the following missing is why it needs why. Oh, okay, so basically it cannot do a sorry, so because it's a bar plot, it cannot convert. It needs, because for a violin plot we need two different information. So, but essentially, let me try something different. So I'll show you the violin plot graph in a moment. But the idea behind is, let's say p plus geom bar. You can displays the bar graph. You can simply say p plus any other graph that takes basically a single variable. You can use those ones. So you can say so p plus geom histogram. Actually, that could be the other one. Histogram. Again, it's giving the information. Why is it giving? Okay, the histogram is. Oh, histogram is again not going to work because histogram builds the frequency based on binning the values. So we already have actually categories. We only have categories. So I think that won't work. Okay, so sorry about the whole confusion. But okay, here we created a p variable that holds this information. And when then to this p, we can keep adding these ones, like I said, geom bar. So essentially this, if you want to use the same data to any other kind of graphics you want to generate, we simply can say p plus that particular graph type or that particular geometry. We don't have to rewrite this whole line again. So that can help you save some time with respect to that one. So here doing exactly the same. H is x-axis is miles per gallon, but this time I'm building a histogram. So it takes the miles per gallon and then bins the values, and based on binning the values, it builds the histogram. So the default bin number is actually 30. So you can, so that's, I think, pretty big for the number of observations we have. So we can change that value to a smaller value. Let's say change to 6, and then can change your display differently. So you can define the number of bins you would like to use. And how many bins we need to specify entirely basic is going to depend upon how we would like to display the information. So yeah, there is again comes from the user. ggplot cannot has a default values, but sometimes, as we can see in this case, the default value bin is 30, but not really an ideal to use it. We can also specify the bin widths. So if you want to split our whole data set, what's the bin size, bin width should be, or bin size should be. So this can be specified using bin width. So here we are using the width of each bin to be 5. Then it's going to generate the graph based on that one. And it has two parameters. One is called color and fill. So color will color only the boundaries or the shape of boundaries, and fill will color the each of these bars. So if you say fill color equals to blue, it only tells you the boundaries. But if you say fill equals, oh, sorry, what's the fill? Fill equals to light blue. No, where was it? I missed it. Oh, fill equals to red. So this is what we're trying to execute. So why is it not execute? Sorry. All right, okay. No, it's not executing primarily because I created this object. And so I have generated the graph, but I have generated the graph and saved it into p variable. Now, unless I called p variable, it's not going to display the information. So now I have to type p in order to get this graph out, because this is stored inside a variable. It's something same as x equals to 2. So if you create x equals to 2, that 2 is not displayed here. Unless you say x, then it displays what information does it store. Same thing is here. The whole thing is stored into the variable p. Unless you call p, the graph is not basically displayed over here. Let me get rid of this one over here. But again, it's a geom histogram bin width. I think it's pretty much the same. They're changing the bin width size. Essentially what I'm trying to just playing with the changing different bin width, and then you'll see how the data is actually changing and which one actually looks more better. You can use those ones as you like. Okay, now what does the H does here? So H, if you look at the top, H, it just stores this particular information. So what we are doing is ggplot is specifying that the empty cars is our data frame. Of that one, we are setting up x equals to miles per gallon. Okay, that's the value we are picking up. Now using the H, we can set H plus geom histogram. So we use the same H, and we could do using that one, the histogram plots, which was the previous one, and we can use the same H to do the density plot. So the H will represent what information, what data, which data frame and which column we are using. So since we are using the same one across both the plots, so we don't have to rewrite everything if you specify into a variable. So it helps you reduce the number of lines you're coding. And so again, it's entire, there is, I won't say one is better over the other one. So I would not say, for example, whether I would not say that whether assigning to the variables is any better than not assigning. It is entirely how would you like your code to be, how you like your code to be written. So if you like it to be set it up to variables, then this is the way to go about it. If you don't like it to set up to the variables, then you can write the whole line of code for each of these ones. Both of them are perfectly fine. None of them is better over the other one. So that's a perfectly fine. So finally towards the end, so we did the density plots. Now here what we are doing is we are doing now a box plot over here. So in order to do a box plot, so is again the whole box plot is getting assigned to p variable, so we have to type p to get it. But what empty cars, x equals to, we want to, again, when we're trying to do a box plot, we want to group our data based on certain you can say categories. So we want to put the cylinders, so 4, 6, and 8. And for each of the categories, we want to show the box plot information is miles per gallon. And you can say geom box plot. And in that one, we can say color equals to black. So the boundaries would be black, and it will be filled with the light blue cars, light blue colors. So now I have executed that one, and this is what we have generated over here. So this is the box plot you can see in terms of those one. Okay. Now here what you can see is neat one, but sometimes you would like to look at your data also. So you can also add the existing p. So you did the whole box plot. Now you can say p plus geom point. So what it's going to do is it's going to display the miles per gallon data in each of the different categories. Okay. And there is a problem here, is like, for example, let's say at this point, which we cannot see, there are 2 data points over here, one above the other one, right? But because they're in a straight line, but they have the same miles per gallon information, so the data points are exactly on top of each other. So it doesn't tell us about the density, or basically tells about how many data points are here at each location. So what we can do is we can spread these data points rather than overlapping each other. So that's where you use something called jitter function. So here what I'm doing is using the same p plus geom point, and inside that one I'm changing certain characteristics of points. When the size is equals to 3 and position is equal to jitter. Right now it's not jitter, so when you do jitter, that's how it's going to look like. So the points are, I think, a little too big. So let me change the size. Maybe one. Let's try how does it look. Okay. So as you can see, these were 2 data points. So in our previous plot, when we did it, p plus is simply the geom point. these two data sets were exactly on top of each other. So we could not see how many data points were there. But if you use the jitter function, they are distributed and you can see how those ones are. The only thing is like now they're distributed all across the whole box. So we don't want to spread too much wide. We want to narrow it down. So there is again a parameter which you can say, so position is equal to position underscore jitter, and you can say width equals to 0.2. So it's going to cut out 20% on either side of the box, and then plot within the remaining space, which is going to put the data points. So it doesn't plot close to the edges, so all the data is spread within a very narrow range over here. Okay, so we did geom point, so we can also do here as geom underscore violin plot. So that's what I was going to show. So you can do a violin plots also. That's okay. Because previously there is a bar graph, basically the box plot. So it's adding a geom violin plot on top of it. So that's why it looks that way. But essentially, if we take this data from this code from here, let me put in another line somewhere. Okay, maybe over here. And to this one, I say I'm looking only on geom underscore violin plot. It's only going to show me the violin plot. You can color it, then I add the statistics color, like whatever the color you would like to. You can say color equals to red. We're going to give you red color lines because in order to fill it, you have to say fill. Fill equals to, I think, true, or fill equals to color. Fill equals to, again, you can say red. It's going to be too bright, so we can change the alpha value. Alpha equals to 0.3. Now this is how you can look at the box plot. Now the violin plots are better, in my opinion, over box plot. So you can see that the distribution of data point is sort of like bimodal here. So there's a quite good number of data here, and then another peak. You can see sort of like, I won't say the peak, but yeah. And then here the distribution is skewed towards the higher, and this is pretty much the data of the distribution is of that particular type. So I will stop here because I think we're already 3 minutes over the time. And the next time we will talk a little bit more about the other parameters that are that can be defined or can be used to basically code a lot more information in these plots. Stop recording.